URLs, site links, web addresses, URIs. So many names are used on a daily basis by developers and internet users to describe the standard used by the web to enable us locate pages and resources. In this HTTP Fundamentals video, we'll be diving into the exciting world of HTTP URLs. And by the end of this video, you will not only fully grasp the purpose, structure, and benefits of URLs, but you will also know the difference between a URL and a URI. My name is FK, and welcome to the Fundamentals of HTTP as we study how URLs work. But before we go into URLs, let's first take a quick look at how the internet was used before URLs became a default standard for accessing resources. Back then, you couldn't just open your email or download files using a web browser. To read the news on the internet, you would need a special newsreader software. To download or upload files to the internet, you will also need an FTP client to access files on an FTP server. And for your email, you would also require an electronic mail program to send and receive email messages. But today, you can simply do all that and many more from your web browser by typing this magical thing called a URL. How convenient is that? This convenience takes a major credit in how much we use the internet today. So, how did URLs come to be the default standard? URLs are actually a subset of a standard HTTP definition called URI. URI stands for Uniform Resource Identifier, and it was designed so that clients can point at resources that they are interested in on the internet using the resource names. More like postal addresses of the internet that can be used to uniquely identify and locate information or resources on the web. Now, URIs come in two different types: the URL and the URN. This video does a deep dive into URLs, so let's take a look at URNs first. URN stands for Uniform Resource Name. URNs were created to give a unique name to every resource on the internet, allowing the resource to be accessed without knowing its location. What this means is that, with the name of a specific resource on the web, you can always access the resource using the same link even when it is moved from one server to another. This location-independent strategy allows URNs to be highly portable and stable. An example of a URN is URN:/IETF:/RFC:2616, which is the URN for the RFC document that defines the HTTP 1.1 standard. URNs are commonly used for research and white papers like this one to ensure that they remain readily accessible without having to worry about the servers hosting them. URNs are also designed to be accessed using multiple network protocols and not just HTTP. Now you might ask, URNs seem like an amazing idea, so why are we not using it everywhere? The first reason I will state is that the URN standard started off as being experimental, while URLs were already rapidly catching on. So, they were not widely adopted. Also, URNs require special infrastructure to support how they resolve to resource locations, and lack of such infrastructure has further affected their adoption. However, they are still in use today in some not so popular corners of the web. Now that we know that the main definition of resource identifiers on the web is URIs, and that URIs come in two flavors, the URL and the URN, and we have also taken a quick look at what URNs are all about, it's now time to explore the amazing world of URLs. So, what are URLs? URL stands for Uniform Resource Locator. Uniform because it's universally used as a standard. Resource because we use them for resources. And locator because they are signatures for accessing the location of a resource. So, to simply put it, we can say a URL is a uniform standard for locating resources on the internet. Every web user uses URLs. Casual users type it into their address bar every day and click links to load pages and images. Like this URL that gets a profile image from Facebook. Application developers also use URLs to construct web page navigation, point at resources, call APIs, and so on. Unlike the internet's dark days, today, you can point to any email, file, or newsfeed to access it using a web client like the browser. You can point to emails using a URL like this that uses the Mail2 protocol, or point to files using the FTP protocol with a URL like this, or even a streaming service with this type of URL. Now that we get the gist of URLs, how are they actually constructed? Why do we need the colons and forward slashes? What starts a URL? What ends it? And what does this all mean? To begin understanding a URL, we will first look at a basic one. After that, we will then expand to a full URL structure breakdown. Sounds fun, right? Let's begin. First, let us look at a simple URL, one that is similar to what we see on the web every day. In its most basic form, a URL tells three things: how to get a resource, where to get the resource, and what resource you are to get. In the URL we are currently looking at, the HTTP colon part of the URL is what is telling the server how we want to get the resource. It is telling the server that we'll be using the HTTP protocol to request the resource. The part of the URL that says www.facebook.com is the part that defines where we are getting the resource from, which is the domain name of Facebook. This part could as well be replaced by the IP address of Facebook's servers. And lastly, we have the part that reads /images/profile.jpg. This part tells the server what we want to get, which is the JPEG image in the images folder with the name profile.jpg. In summary, this URL defines how to get the resource, which is HTTP, where to get the resource, which is www.facebook.com, and what resource to get, profile.jpg in the images folder. Got it? Awesome. Hello guys, this is FK, and honestly I am tired of all the debates and arguments I'm seeing on Twitter and Reddit about which programming language is better or which framework is better. While many developers are still lacking in the understanding of how programming languages work, how databases work, how web servers work, and how even software systems work. Lack of understanding of these main fundamentals has been the reason for things like imposter syndrome, not knowing whether you're programming the right way, or even struggling to try to be a senior developer. So, I have taken it upon myself to teach these core fundamental topics. These topics never change, and they form the bedrock of any proficient developer, DevOps, cloud, or blockchain engineer. So, if you want to get free materials and videos sent to you every week, use the link below to join our fundamentals community. I can't wait to share exciting software fundamental lectures with you as we all strive to become better software engineers. This already gives a basic understanding of what URLs are all about. But we are not here for just basic knowledge. We are here for a deep dive. So, let's dive right into the full structure of a URL. Oh yeah, this is what the full structure of a URL looks like. This is the standard syntax of a uniform resource locator, and we'll be looking at each component one by one. Now, don't be intimidated by this structure. It's actually quite comprehensible, and we'll be starting with the scheme. The scheme part of the URL is what defines how to access a resource. Simply put, the scheme tells what protocol the URL is to speak. For HTTP URLs, the scheme can either be HTTP or HTTPS, depending on whether you are making a non-secure or secure connection. This part of the URL must start with an alphabetic character. It is case sensitive and is separated from the rest of the URL by a colon character. Next, we have the username and password section. This section is for servers that require authentication through a username and password before the resource can be accessed. An example of servers that use this often are FTP and database servers. For example, this FTP URL uses the username Fiki and password fundamentals to authenticate the user on an FTP server in order to access the PDF. Most of the pages we visit and resources we access on the web are public, which is why you see this section mostly omitted, just like in our previous basic URL example. Separated by an @ symbol right after our username and password section is the host and port section. To access a resource on a server, the client application needs to know where the server is hosted and where on the machine the server is running. The server location is what is defined as the host, which can be a domain name or an IP address. On the machine with this IP address, the server software is running at a specific port number. The combination of the host address and the port number, separated by a colon, helps us locate the server that is hosting the resource we want to locate. Makes sense, right? For the web, an example of a host and port combo will be facebook.com:80 or 157.240.192.0:80. The port for web servers is always 80, and because this is the default, it is almost always ignored in the URL and assumed by the client when using the HTTP protocol. This is why we don't always see or use port numbers when writing most of our web URLs. If you are using the secure HTTPS protocol, the port number switches to 443 as the default. Next in the sequence of the HTTP URL syntax is the path component. This is the path, no pun intended, of the URL syntax that specifies where on the server the resource we are trying to locate is residing. In the example URL displayed, this will be /pages/about.html. This is the information the server needs in order to locate the resource. While there might be more considerations for a case like virtual hosting, for the scope of this video, this definition holds for all cases. Next, we have the parameters section of the URL. Path parameters in URLs allow you to add additional information that the server will need to attend to your request. For example, FTP servers have two transfer modes, binary and text. You can use path parameters to specify the exact transfer mode you want. For example, binary for images. In the example shown, a custom path parameter res has been set to the value high to tell the server that we want the high resolution versions of the images for this folder for our index page. These days, path parameters are not so popular for providing information as the section we'll be going to next, which is query parameters. However, path parameters still have a lot of benefits, including their ability to provide data to individual sections of the full path, just as we did with the images folder in our example. Next on the list is query strings. A query string is everything to the right of the question mark after a URL. By convention, query strings are name-value pairs separated by the ampersand character. They have grown in popularity over path parameters for passing arbitrary information along with the URL. Like this example, where we are instructing our PHP script to fetch 10 rows from page 3 for the products page. HTTP does not specify a standard requirement for the format of the query component. However, some characters like carriage return, newline characters, pound signs, and plus symbols are not allowed. And finally, we have the last component on the URL syntax, the fragment. Fragments allow you to break down a resource into smaller sections or parts. This allows a client to jump between different sections of a single resource. While a lot of resources are not supported, a very common resource that makes use of fragments is HTML. With fragments, you can access subsections of an HTML page. A fragment can be implemented by adding a pound sign at the end of the URL, followed by the name of the fragment. This way, once the URL is loaded, it navigates automatically to the section defined by the fragment. For example, let's say we have an about.html page on our website. This page can be subdivided into smaller sections like services, team, contact, and so on. With a fragment, we can use a URL like this to jump to the team section of the about page. Pretty neat, right? Do note that fragments are not processed on the server. The server still sends the full resource. The client is then responsible for identifying the fragment and navigating the user to the specified section of the resource. There is an HTTP concept known as range requests that actually allows a client to request only a specific portion of a resource. But that is beyond the scope of this video. I'm sure we'll be touching that topic someday, and you can also suggest topics for me to treat in the comment section. If you're still watching this video at this point, you are a real one. And I am excited by your thirst for knowledge as someone who shares the same passions. So, that's all we'll be learning about URLs today. And I hope you can now confidently say, I now understand URLs. Feels great, right? Till I see you again in another video, go be the best you can be.